Now we are going to discuss the second type of magnetic materials, which are called diamagnetic materials. The diamagnetic materials are defined as these are those materials or substances in which the orbits and spin axis of electron in an atom are so oriented that their fields cancel the effect of each other so that their resultant field is zero. Dear students, now let's discuss the effect of external magnetic field on diamagnetic materials. Here a question arises in our mind that explain the effect of external magnetic field on diamagnetic materials. So the answer to this question is that when a diamagnetic substance, for example copper, zinc, bismuth, is placed in a magnetic field, the substance is weakly magnetized in a direction opposite to that of the applied field, as shown in the diagram. Therefore, a diamagnetic substance is weakly repelled by a strong magnet. Now, let's discuss some important properties of diamagnetic materials over here. And a question arises in our mind that explains some different properties of diamagnetic materials. So the answer to this question is that the susceptibility of a diamagnetic material is negative. The susceptibility is independent of temperature and external field. The magnetization becomes zero on removal of external field. Magnetic effects of diamagnetic materials are very weak. In an external magnetic field, they get magnetized in a direction opposite to the field and they have a tendency to move away from the field. If suspended freely, they set themselves perpendicular to the field. Now, here's a video regarding different properties of diamagnetic materials. So let's watch this video.
Diamagnetic substances are repelled by a magnet, copper, silver, water, gold, antimony, bismuth, mercury, quartz, and diamond are some examples of diamagnetic substances. 2. They are magnetized feebly in opposite direction to the applied external field. 3. When suspended in a uniform magnetic field, it comes to rest in the perpendicular direction to the magnetic field. 4. Diamagnetism does not depend upon temperature and does not obey Curie's law. 5. When it is kept in a non-uniform magnetic field, it moves from the region of greater field to the region of less field strength. 6. Hence, the susceptibility is negative. 7. The magnetic lines of force passing through these substances are less than those in vacuum. So the relative permeability is less than 1. 8. A diamagnetic liquid is taken in a U-tube and arranged so that one of its limbs is in the uniform magnetic field. The liquid in that limb is depressed. 9. The atoms of the magnetic substances do not have the resultant magnetic moment. 10. When a diamagnetic liquid is taken in a watch glass and placed over the magnetic poles, which are nearer as the field is strong at the midpoint, the liquid gets depressed. When the poles are separated to a larger distance, the liquid rises up at the middle, as the magnetic field is weaker than the poles.
Now we are going to discuss third type of magnetic materials, which are called ferromagnetic materials. The ferromagnetic materials are defined as those substances which exhibit strong magnetism in the same direction of the field when a magnetic field is applied to it are called ferromagnetic materials, as shown in the diagram as well. Now, it's very important to discuss the concept of domains in ferromagnetic materials. In these substances, the individual atoms act like tiny magnets. The interaction between these tiny atomic magnets is so strong that it line up parallel to each other even when no external magnetic field is present, as shown in the diagram. And these tiny magnets are called magnetic domains. The size of these domains is very small, of the order of millimeters or less, but large enough to contain atoms from 10 raised to power 12 to 10 raised to power 16. In case of ferromagnetic materials, Curie temperature has a key role, and it is defined as there is a temperature above which the ferromagnetic material will turn into paramagnetic material. This particular temperature is called as Curie temperature, as you can also see in the graph as well. Now here we are going to discuss some important properties of ferromagnetic materials, and here a question arises in our mind that explain different properties of ferromagnetic materials. So the answer to this question is that when a rod of ferromagnetic material is placed in a magnetic field, it rapidly aligns itself in the track of the field. Second, it is strongly attracted by the magnet. Third, the ferromagnetism mechanism is not present in liquids and gases. And fourth property is the intensity of magnetization, magnetic susceptibility, relative permeability, and magnetic flux density of this material will be always prominent and positive. Now here's a video regarding different properties of ferromagnetic materials. So let's watch the video.
Strong magnetic properties are called ferromagnetic substances. Iron, cobalt substances. Substances exhibiting strong magnetic properties are called ferromagnetic substances. Iron, cobalt, nickel, steel, alnico, etc. fall under this category. If an iron rod is suspended in magnetic field, it quickly aligns itself along the direction of the magnetic field. A ferromagnetic substance, when placed in a magnetic field, is strongly magnetized in the direction of the magnetizing field. Temperature has an adverse effect on a ferromagnetic substance. Due to rise in temperature, a ferromagnetic tends to lose its magnetism.
Dear students, now in the end, I would like to share the success criteria for this topic. So please try to remember the definition of magnet and magnetism, different types of magnetic materials, properties of paramagnetic, diamagnetic and ferromagnetic materials, and Curie temperature for ferromagnetic materials. And that's all about our today's lecture. I wish you all the best. Stay safe and healthy. Allah Hafiz.